Hi, in this video, I'm going to talk about the ingredients, the primary ingredient of concrete. The primary ingredient of concrete, we know that it's cement. So, the cement, its properties. Uh, the ingredient of concrete are several, the main three ingredients. First is cement, next is fine aggregate, coarse aggregate, and the next one is water. In that, the binding material is cement. So, apart from cement we can't make concrete. In that case cement plays a very important role in making the concrete, so we are choosing cement as the primary ingredient, and we are looking forward what are the main properties of the cement. So the primary main property of the cement is its compressive strength. So what is compressive strength? Compressive strength is its ability to resist compressive loads measured by testing mortar cubes. So we'll be making cubes using mortar. What is mortar? It is simply cement plus water mixing. So this mortar will be poured in mold of like cube shape. In that cube shape, we will be strengthened means as time goes it will get set and it will form a very hard cubical cube substances, I mean cubes. We will get very hard cubes. So these cubes will be taken under the compressive loads and will be measured uh, how much load it can bear. So minimum strength are prescribed for different grades such as 33 MPa or for 33 grade concrete after 28 days, and specific values are tested like 3, 7 and 28 days of ordinary Portland cement grades like OPC 53. So 3, 7 and 28 I mentioned here are the days. So every 3 days we will be getting the cubes, and under the compressive test load we will be finding the how much load it can able to bear, likewise in 7 day and likewise in 28 days. Of what kind of cement we are using is ordinary Portland cement of the grade OPC 53. This test is crucial because cement is primarily used in compression, and the test ensures the durability and strength of cement based structure. So the ability of hardened cement, once it has been mixed with water it will get hardened to withstand compression, is its most important property, making the strength test vital for construction. This From that we can able to understand how durable the cement is. Knowing the compressive strength helps ensure the strong structures long term strength and integrity. Next, we are talking about the tensile strength. As we always know, tensile strength of the concrete is very much less. So the tensile strength of cement is very low compared to its compressive strength, typically measuring only about 10% of its compressive strength. As the concrete is weak in tension and very strong in compression, likewise cement will be very strong in compression and weak in tension because cement is a primary building agent. So it's often considered as negligible in structural design, necessitating so for exhibiting the tensile stress or tensile force we are infusing steel into it, because steel is the major component that possesses high tensile strength. Mm, So this tensile strength, everything will be handled by the steel, and the compression, everything will be handled by the concrete. That forms a perfect formula called RCC, reinforced cement concrete. So direct tension tests or indirect method like splitting tensile strength or and flexural tests are used to measure this property, with results depending on the testing method and the specific cement paste composition. So low tensile strength means like cement when used to create concrete is significantly weak in tension than in compression. Ratio of compressive strength, the tensile strength of the concrete is roughly 10% of its compressive strength. Then the concrete is good, means like the cement is good for use actually. So that's all about the tensile strength. Here comes the fineness of cement. Actually, fineness refers to how fine or coarse the cement particles are. The smaller the particle size, the larger the surface area for hydration. Hydration is the chemical reaction between cement and water. I talked about hydration. And this reaction is what gives strength to a concrete. If the cement is very fine, the hydration is faster and the strength develops will be very much quicker. That's why in modern construction, especially in high-rise buildings where early strength is important, finely ground cement is preferred. So, however, there is a balance. If cement is too fine, it may lead to problems like shrinkage and high water demand. So, proper grinding of clinker in the manufacturing stage is very much crucial. I'm talking about the silos where the cement is manufactured. uh, about the fineness of the cement. Engineers always check whether the fineness using sieves or air permeability test to ensure the quality of how much fine the cement is. So that's all about the cement. So higher the fineness, faster will be the hydration, and stronger or higher will be the strength. That's all about the fineness. Next, we can talk about the soundness of cement. Soundness is the ability of cement to maintain its volume even after it has set and hardened. If cement is unsound, it means that it will expand later, causing cracks in the structure. This problem usually occurs when cement contains excessive free lime and magnesia. Cement is made up of lime, magnesia, and CaCO3, such wise components. I mean, some ingredients. So, if you think that the the what if you think that it can cause the cracks are happening in this concrete and the cement quality check, while you find out the soundness of cement is not that much, that is mainly because of the excess free lime or magnesia in the cement. For example, imagine building a water tank with an unsound, not that good cement, unsound cement. After a year, cracks might appear and the structure could leak. To prevent this, could we can conduct the Lee Chatelier test. So in this test, cement paste is prepared. Cement paste means cement plus water is the cement paste is prepared and kept in a special apparatus called the Lee Chatelier apparatus. Then placed in water, boiled and cooled. The expansion is measured before and after boiling. So a good quality cement should not expand more than 10 millimeters. So this will ensure that the long-term stability of the structure. Okay. This is about the soundness of cement. Here comes the consistency of cement. So consistency tells us how much water is required to prepare a normal cement paste, depending upon the fineness of the cement actually. This is important because if we add too much water, the strength of concrete will reduce, and if we add too little, the paste will not be workable. To find the correct water requirement, we perform a wicket apparatus test. In this test, a standard plunger, you can see in the diagram, standard plunger is allowed to penetrate into the cement paste. So if it penetrates 10 or plus or minus 1 mm, then the paste is said to have a normal consistency. For example, if the test shows the cement requires 30% water to achieve normal consistency, then this value will be used in further tests like setting time and strength. So consistency acts as a guideline for preparing cement paste with the right water cement ratio, which is very much essential for achieving durable and strong concrete. Thank you. We'll see you the next video.